Hi friends, in this video I am going to show you the development of a cylinder. The question is like this. A vertical cylinder of base diameter 45 mm and axis length 60 mm is cut by a plane perpendicular to VP and inclined at 50 degree to HP and is passing through the center point of the top face. Draw the development of the lateral surface of the cylinder. So here a vertical cylinder is there of diameter 45 mm and axis length 60 mm. A plane cutting plane is used here which is 50 degree to HP, and that cutting plane is passing through through a point. So first step we will draw a circle, a center point. So that circle I am taking as the construction line here. The circle diameter is given 45 mm. Can measure this one, 45 mm. Then for the moment I am removing the dimension line. Now this circle I want to divide into number of sectors so that in the development I can able to show the cutting plane at what points the vertical cylinder is going to be cut. So for that what I will do, I will take a line here. So a radius line I will draw like this, and very simple and advanced method we can adopt here. After drawing this one, go to the select option, select the line, and here patterns are there, rectangle and circular pattern. So of course we need circular pattern. Click on the circular pattern. Here how many sectors we want? So let's say 12 sectors, and angle is 360 degree we need to enter. Then show the center from which point the pattern has to start, means this is the line pattern. So click over this and click on the finish button. So in this way, in 8 sectors we can divide the circle. So here I will take this circle little above, right. So now I'm going to give the names for the circle. In the top view we can see the vertical cylinder as a circle. So this circle I drawn whose diameter is 45 mm, and sectors I divided into 12 sectors here. Then by taking the text command, let's start from this point. So all the points I'm going to locate here. F, this is G, H, this is I, this is J, K, L, like that. So like that, the notations we can give here. Now properly I will show these notations, right. So next I have to draw the front view of the vertical cylinder here. So for that I need to project all the points. So like this. Now the front view. Front view appears as a rectangle. So I'm going to draw the rectangle here. Whose height is whose height is 60 mm. Now these lines just I'm going to project. This is the center line. That one I can show here. This is the center line. Okay. Now the notations we can give here. So let me zoom out this area. So here taking the text command, this point is A dash, this point is B dash, B dash and L dash. This point is C dash and K dash. This one is D dash and J dash. This one is E dash and I dash. This is F dash and H dash. The last one is G dash. So I will rearrange these once again properly. Okay. So after this, we drawn the 65 mm axis height vertical cylinder whose base diameter is 45 mm. If you want, you can show the diameter also here. Below the diameter we can show like this. Next, the cutting plane passing through the center point of the top face and it is having 50° to HP. Here need to take a line. I will take this line here. You can take any reference line. So from this, just you need to draw the line like this and set the angle. This angle you need to set 50°. Next, use the extend and this line will be extended. In fact, this cutting plane will be extended until the last one, the last surface of the cylinder is cut. So here, after using this cutting plane, we have to identify at what are all the generator lines, projection lines I have taken here. The cutting plane is going to cut. So accordingly, we have to give the points here. So for that, I will start from this point here. So here, starting from this one, the line A here, this is 1 dash. Okay. Then B is going to cut here. So this is 2 dash. Then C is going to cut here. This is 3 dash. And D is going to cut here. This is 4 dash. So after that, E is not going to cut, G is not going to cut, H, I is not going to cut. J is going to cut backside. J is the point generator from the base. So which is going to cut here as a number 5 dash. So 5 dash we can give this side. Then after that, K again backside point, backside line we can say generator. So after 5 it is 6 dash. Then after that L is there. This is 7 dash and back to A. So these are the points. Let me rearrange once again these points properly so that you can understand easily how these are. So here this is the A point. This is the second generator. This is the third one. This is the fourth. The fifth backside points I placed just below the cutting plane line, so you can just differentiate that one clearly. Right. So now for this we have to do the development. Here in the development, what we are going to do, this is a vertical cylinder. Simply we are going to unfold it for. So after unfolding here, as 12 sectors I have created, so 12 equal parts, so I have to divide that one. So before that, when it is unfolded, it appears as a rectangle, a plain sheet rectangle. So for that, I need to draw a rectangle here. So for that, this Y I'm just shifting here, right? So in fact, this XY line you can extend, like, let's do this one. This one I'm going to extend. If you want, you can do like this, or independently also you can draw, right? So here, this line I'm taking the projection line here. This one I'm projecting this side, this end, like this. Now I'm taking the rectangle with construction line. You can do. Now, how to find the length of this unfolded cylinder? So it is simple. For the cylinder, the length we can calculate as pi into d. So d value is 45. So for that, I'm measuring this one here. Here in this field, pi value is 3.14 into d value is 45. Let's enter this one. So 141.3 mm it comes. After this, here, how to divide this one into 12 equal parts, that is these sectors here. So to divide that one manually, we are drawing a inclined line. So 12 parts in the sense, so 12 equal parts, that line we are dividing, like this one here we are drawing the line here. This one with 12 parts we are dividing this one, and we are connecting this one, that line into back like this, and all the lines we are connecting like this. So 12 lines we are going to get, and 12 equal parts we are going to do manually. So here I will use the shortcut here. Simply I will take a line here. Let's say projection line I will take. So I will draw a line here. I need 12 divisions here. For that, I will measure this, and the dimension of this one I will enter as 141.3 by 12, the 12th measurement. So here I got 11.78. Now what I will do, I will make use of this one. I'm going to use the offset here, single selection. This is the line I'm selecting, and value I'm going to enter here 11.78. Say yes, then just go on offsetting until the entire rectangle, which measures for 141.3, divided into 12 equal parts. So after doing this one here, so just I'm going to remove the dimension lines, not the dimension. So all the dimension lines I'm going to select. I want to have clear picture. For that I'm going to delete that one. So equally, this is divided into 12 equal parts. Now let's give the names here. So start with the A. Here, this is the A point. A, this is B, this is C, D, E, F, G, H, so I, J, K, L, and back to A. So these points again I am going to rearrange for the each sector properly. I am going to arrange this one. This is A, You can use other notations also. Other notations in the sense here, after GH, IJK, instead of IJK, LMN, you can use there, so that the identifying the things is very easy. Now, after that, these cutting points from the plane we need to transfer here. So as we are observing here in the front view, this portion is going to cut. So here, this one I am going to, the below portion we are going to develop here. The above portion is the cut portion, so that this cut portion I am going to uh, make the thin here. Like, I'm going to use the split option. This line I'm going to split at this point. This line I'm going to split at this point. So after that, this one I am selecting and making thin. Normal line you can use, so that the front view shows clearly the cut portion of the vertical cylinder. So this side, how to develop this one, this up to this point we did. After that, from each and every points here, 1 2 3 4, 1 dash, 2 dash, 3 dash, all those things we need to transfer the lines here with respect to the generators. So like, over the A, the 1 dash is there. So what I will do, I will take the line here. From this I will start. So here 1 dash comes here over the A, and on both sides here, means both the ends here. So just connect this one like this. This one I am use, it will be the projection line. So simultaneously I will give the notations. This is 1 dash, this is also 1 dash, then 2 dash. So from 2 dash, which is the or which point or which generator coming from the B, vertical line B. So this is the B. Over the B, let's take the line again. So here we'll zoom out this area. From B, so 2 is on, 2 dash is on B, so 2 dash is on B here. So this is 2 dash, this is 1 dash, next 3 dash. So for 3, from this, so 3 dash is on which point, which line, C line. So over this C, connect this here and give the name. This is 3 dash, 3 dash. So let me reduce the font size of these notations. These are appearing very much big. So that conveniently we can place them properly here. Right. After that, 4 dash, 4 dash is on which line here? D line. So over the D line here, 4 dash will come. So this is the point, 4 dash. After 4 dash, we have 5 dash. 5 dash on the back side over the J. It is on the back side over the J. So that means here the 5 dash will be here. 5 dash. Next 6 dash. 6 dash on the back side K line. So this is the line I need to extend like further. So the same line. So this is going up to in front 3 dash over the C, backside 6 dash over the K. So where is the K? K is here. This is 6 dash. 6 dash. Next, I have 7 dash. 7 dash, that is 2 dash and 7 dash. 2 dash on B line in the front side. Back side it is over the L, 7 dash. So let's extend. This line is up to 2 is already there. So this will be extended up to KL, L over the L here. This is 7 dash. 7 dash. So like that, all the points I have generated here. Now let's connect this one with the curve. So for that you can use this curve from the 1, 1 to 2, 2 to 3, 3 to 4, 4, okay, up to 4. Connect is disappearing. I will split this line at this point so that I will get the endpoint symbol. Once again, curve I'm taking from 1, 1 to 2, 2 to 3, 3 to 4, right? Then this side again curve. It is already the visible line is there from 4 dash to 5 dash. Now 5 dash to 6 dash, 6 dash to 7 dash, 7 dash to back to 1 dash is connected. After that, what are the things we need to highlight here? So this curve we need to highlight. This line is already there, 4 dash to 5 dash. This one we need to highlight. So this one I am making visible. Then use the split option. This line has to be split at this point. This line has to be split at this point. This line has to be split at this point. Once again, this line has to be split at this point. So in steps, I am going to highlight and de-highlight the lines here so that you can understand what are the visible, what are the hidden lines. So this one I'm taking normal lines. These are the cut. This is the cut portion here. Then among the parts here, these sections what we made. So these are to be. This is also. These are also we are highlighting. This is the actual curve. So these you can make normal, or you can leave as it is projection lines, or make these are black color normal line. So like this is what the development here. You can use the text command by increasing the text size. I will type here. development. Yes, this is the way how we can do the development of a vertical cylinder whose diameter is 45, axis 60 mm height, and a cutting plane traveling traveling at a point of the top surface and having the angle 50° to the HP. So that's all, guys. If you like my video, do subscribe and share. If you have any doubts, any comments, you can put in my comment box. Thank you.